Hello, good evening all. Am I audible? Am I audible to you? Please wait for 2 to 3 minutes. Okay, let all join. Then we'll start. Student, are you able to hear me clearly? And my screen is visible, I think. If it is not, then please tell me. Okay, thank you very much for responding. Okay, so today I will discuss assignment which given in last semester, and also I will give brief about the lectures which are taught in week second, uh, and assignment of first week, and assignment of first week we will discuss in next week because deadline is not over yet. So I advise to solve assignment after deadline of your current course. Okay, so it will be solved in next week. Today I will solve previous year assignment. Before that I will discuss a little bit about what is going on in second week. Okay, brief lecture about the second week, then we will discuss about the assignment. It will help to solve the assignment of your second week also. Okay, I think we should start now. It is 7:03. Okay, so in analytical chemistry, in second week, sir discussed about the role of analytical chemistry. Okay, so what is the role of analytical chemistry? What are the tools and techniques are being used in analytical chemistry? Okay, then some separation process, then how to do dry acing. Okay, then wet acing. Dry acing we have already discussed in first week. In this week wet acid is discussed. Then how sample prepared, how we can weight of sample. Okay, so these are the major points. Filtration, ignition. Okay, so these are the major points we will discuss in this lecture. First of all, I will start from the role of analytical chemistry. Okay, so we all know that before using anything, we need purity of this thing. Okay, like suppose you are taking any drugs. Okay, so it is very important that the purity should be required. Okay, required purity should be there. Otherwise, this drugs can be poison for you. Okay, that's why we are generally check the expiry date of a medicine. Okay, why we are checking it? Because after some time, due to degradation and due to oxidation, some new product will be generated in medicine. Okay, and it can harm for your body. So how we will analyze this type of things? Okay, how doctor will analyze that you have a low hemoglobin. Okay, so this is the role of chemistry, role of analytical chemistry. Okay, so we will analyze the sample. Okay, so to analyze sample, different type of tools, different type of techniques are being used. Okay, so it is depend on sample. It is also depend on the importance of sample. Okay, how your sample is important means if you require purity on ppb level, then you need to precisely examine your sample. Okay, sometimes it required in percentage and whatever. So according to condition of sample, and according to condition, according to importance of sample, we need to select which type of tools and techniques should be used for analytical chemistry. Okay, to understand role of analytical chemistry, here I am going to discuss about the uh, purification of zinc. We all know about the zinc metal. Okay, zinc metals are primarily used for galvanizing. Okay, it is also being used for medicines and like in ore and many purpose, but main use of zinc is galvanizing. Okay, so uh, how we smelt zinc, and what are the steps in zinc, and in zinc industry how analytical chemistry play important role. Okay, how by using analytical chemistry we can purify zinc. Okay, so similarly other metal like iron, aluminum, silver, gold, all are being smelt. Okay, and analytical chemistry playing the same role. Okay, so first of all, zinc ore. Okay, so we are just a minute. Student, please join on time. Okay, now people are joining, so it will make your disturbance. Let me involve just a minute. Okay, good. Okay, so please mute yourself. Okay, if you have any question, you can raise your hand. Then I will ask you question. Okay, so first of all, zinc ore. Okay, so from mining we will get zinc ore. It has around 2 to 3% of zinc. Okay, so only 2 to 3% of zinc. How we analyze here? First of all, please mute Fatima. Keep your mic muted. Okay, so here only 2 to 3% of zinc contain in zinc ore. How we will analyze first? Okay, so we need to analyze by analytical chemistry only. Okay, that okay, this sand we can say, otherwise it is sand only. But if it is has 2 to 3% or more than it zinc content, then we can consider no, it is a zinc ore. We can smelt zinc from this sand. Okay, so it can be considered as ore. Okay, after that we concentrate, or we are enrichment of zinc. Okay, so there are different type of process which are being used, but I will not discuss in deeply. Okay, so by this process we improve zinc percentage. Okay, we are improving zinc percentage. Okay, so after that zinc will be improved like 50 to 60%, 2 to 3% to 50 to 60%. Okay, so now our this ore is called as a zinc concentrate. Okay, because we have already concentrate over zinc. Okay, so here also we need analytical chemistry to measure 50 to 60% zinc. Okay, here we require, because zinc is very higher percentage, so here we require more precise techniques for of analytical chemistry. So generally we use volumetric analysis here. Okay, because whenever percentage is high, we generally use volumetric or gravimetric, and if percentage is low, then we generally use instruments like spectroscopy and like that. Okay, then it is being roasted. Okay, roasting is nothing, we are burning our zinc concentrate in presence of oxygen at more than 800 degree centigrade temperature. Okay, so zinc concentrate is nothing, it is a zinc sulfide, ZnS. Okay, so ZnS in presence of oxygen and at a higher temperature, it will be converted in zinc oxide, ZnO. See here again you need to use of analytical chemistry, because how you will how otherwise how we will measure that how much of zinc sulfate is converted in zinc oxide. Okay, so this process efficiency can be measured by measuring the amount of zinc oxide. Okay, so here also we need analytical chemistry. Hello, my screen is visible now. Okay, okay, thank you. Okay, so we are here. Okay, so it is now we convert zinc sulfide to zinc oxide. It is known as a zinc calcine. Okay, then we do many other processes like sintering. Okay, where zinc oxide agglomerate will generate. Okay, then we add coke. Coke is nothing but carbon, you can say. Okay, here so slag and zinc oxide powder will be formed, then zinc will be vaporized, condenser. Okay, so there are different process and different steps are there. Okay, and each and every step we need to measure how much our process is efficient, and this efficiency can be measured by use of different type of analytical tools and techniques. So this is the one process, but there are many process, and this process are being used uh, for smelting of many precious metals, and where analytical chemistry is backbone to recover this type of metals. Okay, so tools and techniques I already, please mute yourself. Okay, yes, any problem? Okay, so analytical chemistry can be analyzed by classical analysis or instrumental analysis. Okay, so classical analysis means volumetric or gravimetric. So when percentage is high, suppose you have zinc means 60 to 70%. Okay, so if percentage is high, so we will go for classical analysis. But if percentage is very low, or you can say ppm or ppb level, ppm or ppb level, here you cannot use classical analysis. Okay, here you cannot use classical analysis because concentration is very low, parts per million to parts per billion. So that you need sophisticated instrument to analyze this very minute quantity of your analyte. Okay, so that's why we will use instrument. Again, there are qualitative and quantitative analysis we have already discussed in previous week. Okay, so by this both process we can either qualitative or quantitative analysis can be done for sample. Okay, so these are the techniques. Whereas tools which are being used in analytical chemistry, these are very common glassware which are represented here. Okay, it is known as beaker. This is a volumetry. This is known as this is a volumetric jar. Just a minute. What happened? Just a minute. Yes, okay. So now let me note it. Huh. So we are here. So this is the volumetric cylinder. Okay. This is volumetric flask. This is pipette, and this is also this is called as a burette. Okay. So these are the different type of tools which are being used for classical analysis. You can say. Okay. For instrumental analysis, we have different type of tools, different type of operators, which we will discuss in future. Okay. So just a minute. Total 24 joule. Okay. So these are the techniques and tools which are being used in analytical chemistry. Okay. So what we will do? Okay. To analyze any sample. Okay. So what will the okay? What will our steps? So first of all, we need to sample preparation. Okay. So generally from mines, or if you are going to prepare some solvent, whatever, the sample are in big size. Generally it are big chunks and like. Okay. So what will you do? First of all, you will make you will decrease the size of sample. Okay. So SA method is being used, where solid is crushed, pulverized and grind to make smaller piece of sample. Okay. Which can be used for analysis. Okay. So so this method is very time consuming. Okay. And we use here crusher, grinder, hammer mill. Okay. That's why it is also labor intensive, as well as it is error prone, because there is a high chance of contamination. Okay. Whenever you are going to crush, grind, or hammer your sample, it is high chance that it can be contaminated. Okay. Because it will be done in a larger scale. Okay. Then it will be converted in solution. Okay. So if you are going to measure your solvent by volumetry, you need to prepare solution. Okay. So how you will prepare solution? So just a minute. Okay. So here you will use some digesting agents like acids, base. Okay. By that you can convert your solvent in solution phase. Okay. Please mute yourself. Okay. Please keep your mic muted in the class. Okay. So then suppose dissolution after dissolution you need to identify that whether my solvent is completely dissolved or not. Okay. So how you will do it? Okay. So means you need to check your sample, is it dissolved or not properly. If small type of chunks or small type of particle if you are able to find in the solution, then it might not dissolve completely. Okay. So you need to use more harsh solvent like aqueous and like that, and you need to confirm that your solvent is completely dissolved in your solvent. Okay. So these are the things. Then one more thing I just want to okay. So before preparing sample, we are talking about the sample preparation. Okay. Just a minute, let me write here. Okay. So in sample preparation you will not get pure sample always. Okay, it might be it means if you need solid sample, but it might be mixed with liquid. Okay, some gases can be there, and it will create problem in analysis process. So separation of sample is required. Okay, and it is also included in your sample preparation step. Okay, so just a minute. So suppose it is a solid sample. Okay, so you can have three type of solvent, three type of samples. Sorry, solid, liquid, or gas. Okay, so suppose it is solid sample and it is mixed with another solid. Okay, if you have solid sample and it is mixed with another solid and you need to separate it. Okay, then how you will separate? So here we can use density flotation and solubility difference. Okay, so first of all we will discuss about the density flotation. Okay, so suppose this is your beaker which contain some type of solvent. Okay, and you are putting a sample which is mixture of two type of solid. Okay, and if you drop this sample in your solvent, okay, so what will happen? Density flotation. Okay, so suppose you have two type of solid, A and B. Okay, and if A has lighter density compared to B, so A will be float on the surface of this solvent like that. Okay, whereas B will be deposited or precipitate at the bottom. Okay, so by this technique you can separate solid from solid. Okay, it is known as a density flotation. Second, okay, then second process is solubility difference. Okay, solubility difference means like your solid A and B. Okay, and you are going to mix it in any solvent where only one solvent is soluble. Okay, so what will happen? Your another solid will be precipitate. Okay, and you can filter it and you will get pure A. Okay, so by solubility difference also you can purify solid from solid. Okay, then second is solid from liquid. Okay, how we can separate liquid sample from the solid sample from the liquid. Liquid means suppose calcium carbonate, CaCO3. Just let me write down. Okay, okay, CaCO3 dot XH2. Okay, what is meaning of this chemical formula is that this calcium carbonate contain X amount of water. Okay, so this is means we can solid is in liquid is present in solid matrix. Okay, So simply it can be removed by heating only. Okay. So if you provide heat, the water will be vaporized and you will get pure salt. Okay. So this techniques is used before for sample preparation. Okay. And generally for complete this purpose we used oven. Okay. We use oven. So oven can be heated around 50 to 60 degrees 100 to 200 degrees centigrade temperature, where we can verify this. Okay. Okay. Then gas from solid. Okay. So how we can separate gas from solid? So the example of gas in solid is rock. Okay, rock contain generally radon, Rn. Okay. So how we can do it? We can melt and we can purge it. Okay. So by purging with the inert gas, the gases present in solid sample can be removed. Okay. So student, if it is only 40 minutes class, so if this class is ended, when this class will be ended, you need to join the same link again. Okay. Okay. So second is how you can separate solid from a liquid. Okay. How you can separate solid from a liquid? So it is very simple technique. You all know about this. This is the filtration. Okay. By filtration you can remove solid from the liquid. Then how we can remove liquid from liquid? Okay. How we can remove liquid from liquid? Okay. So for that we require distillation. Okay. So in distillation, what is the principle of distillation? I will just explain little bit. Okay. So in distillation, suppose this is your globe jar. Okay, where you have liquid of two type. Okay, so I am just making different color. These both are miscible. Okay, so we will not identify by visually, but to understand I am just making a different color. Okay, so what will happen when you will heat it? Okay, this is the burner. When you will heat, okay, and if you connect by one condenser here like that. Okay, I cannot draw perfect picture, but I just want to explain it. That's all. Okay, and here okay, so what will happen when you heat it? Okay, suppose here you have suppose you have two liquid A and B. Okay, you have two liquid A and B in this jar. Okay, and when you will heat it, the liquid which has low boiling point will be vaporized and it can be collected in different container. Okay, so suppose A has low boiling point, A has low boiling point, then it will be vaporized first. Okay, and it will be separate like that. Okay, so this is the simple distillation process from where you can separate liquid from liquid. Okay, if you have any doubt you can ask. Okay, you can raise hand and you can ask. Second is decantation. Okay, decantation is also very simple technique. I think you know about that. Okay, suppose there are two liquid, okay, and their densities are different. Okay, suppose this is the first liquid which is circular bottom, and another liquid is like that. Okay, so these are the two liquid, one is in green color and another is in blue color. So when you tilt it, okay, when you tilt this beaker, first green solvent will be you can remove green solvent first. Okay, so by this is the simple method. Okay, and by this method also you can separate. It is known as a decantation. Then okay, liquid to liquid. Then from liquid to gas. Okay, so how you can remove how you can remove gas from the liquid. Okay, so here also same technique, purging. Okay, so when you will purge it, it can be removed. Okay, gas can be removed from the liquid. Third and last is how we can remove solid from the gas. Okay, how we can remove solid from the gas. So we all are familiar with the mask. Okay, generally we are using mask. Okay, so for while corona time, it is protected from it keep your protect from your virus, but it also protect from dust. Okay, so how it will work? Okay, so dust particle which are bigger in size will be not able to penetrate this. Okay, so when you will apply mask, only air will able to come inside, and the dust particle will keep outside only. Okay, so like that you can purify gas from the solid particle. Okay, then how you can separate liquid from gas? Okay, so here also you can filtration of aerosol. Aerosol is nothing but the small particle of air, small particle of water present in air. Okay, it can be also separated by filtration. And finally, how you can separate gas from the gas? This is very challenging job. Okay, we are going to separate gas from gas. Okay, so both are gases and you are going to separate one from another. Okay, so here we need to use diffusion process. Okay, so diffusion process means if you are using on any membrane like that, okay, only one gas will be able to pass. Okay, or if you are using any column like that, just a minute. Suppose you are using one column. Okay, and from this side you are putting a mixture of gases A plus B. Okay, this column contain in a material like that. Let me draw. Okay, these pink birds are representing material which can absorb gas. Suppose these birds can absorb gas A. Okay, so what will happen? A will be remain in this matrix only, and finally you will get only B gas. Okay, so like that also you can separate. Okay, so it is means this same principle is used in chromatography also. Okay, so like that you can separate and purify your sample from one to another. Okay, so we discussed how we can separate different type of sample from one to another. Okay, up to here any doubt you can ask? Any doubt up to here? Okay, so this class is going to end after 4.3 minutes. After 4 minutes this class will be ended, so you need to join sampling again. Okay, okay, so I told you that after means dissolving means your sample preparation, first you will convert your sample in powder form, then you will dissolve, okay, in required solvent. But if your sample is not able to dissolve in any solvent, then what will you do? Then another process is fusion. Okay, another process is known as fusion. Okay, so in fusion what will happen, you need to melt it. First of all, you need to melt your sample. Okay, with and you need to add KOH, NOH. Okay, then it will make solution. Okay, so by this method MnO2 can be converted in MnO4 minus 2 and MnO4 minus 1, and ions, which is nothing but potassium which is potassium, then it is potassium permanganate and potassium magnet ions. Okay, so this all about this thing and the result for your simplification. Okay, sometime to analyze your sample. Okay, sometime your sample in liquid form is very low concentration. Okay, so your sample has very low concentration of the element which you are going to analyze. Okay, or which you need to analyze. So what will you do, how you will increase the concentration, okay, of your element? So you can vaporize it. Okay, so it is just opposite to dilution. Okay, in dilution what we did, in dilution we just add water to dilute our sample, but here the concentration is very low and you need to increase your concentration, because then only it will be suitable for the techniques which are you are going to use for analysis. So you need to vaporize it. Okay, and if you vaporize and if you reduce the volume of the sample, okay, volume of the sample, then the element present in the sample concentration will be increased, and now you can use and now you can analyze your sample. Okay, so this is also one techniques which are you using for sample preparation. Okay, so now we are going to, okay, in evaporation, it is known as evaporation, and in evaporation you need to precaution, because some samples are bumping. Okay, why they are bumping? Because sudden heating in some region. Okay, because when you are going to increase the concentration of the solvent, okay, so please mute yourself. Okay, so due to sudden heating it can bump your sample. Okay, and if solvent will bumping, then what will happen, if your solvent will bump in and it come out from the beaker, then overall amount of solvent will be decreased and it will not give you proper accurate concentration. Okay, and accurate amount of the analyte, because you have lost some amount in okay, while bumping. So it is very necessary to keep an eye on the bumping. Okay, now we will discuss about the wet etching. Okay, what is the wet etching? So in dry etching, what we did in dry etching. Okay, let me write it. Okay, in dry etching, we just put our sample in crucible. Okay, suppose this is a crucible, and Okay, so this will start. Okay, so we are going to discuss about dry acing and wet acing. Okay, so in dry acing, what we discussed, that we need to put sample in crucible. Okay, then then we need to heat it. Okay, we need to heat it. Okay, according to our sample, temperature will be decided according to the sample. Okay, so what will happen? All moisture will be removed, all water will be removed. Okay, and suppose it is it contain filter paper, so the filter paper will be also burned. And generally if you are using for dry acing, we generally use S-less filter paper. What is the meaning of S-less filter paper? Means if it will burn, then it will generate negligible amount of S. Okay, so that's why it will not create problem. Okay, so here okay, so after that water will be removed, filter paper will be burned. Okay, and all the volatile material present in your sample will be evaporized. Okay, and finally student, please mute yourself. Yeah, okay, so finally you will just a minute, let me know. Okay, so after dry acing, you will only the metals or only elements present in the sample will be remain. Okay, in their oxide form. Remaining all other things will be vaporized. Okay, so this is called as a dry acing. But okay, and where dry acing is being used? Okay, so let me explain. When we are going to analyze iron, okay, when we are going to analyze iron, okay, so what will happen? So iron process is already discussed. Deepa, please mute yourself. Deepa, keep your student, please keep your mic muted. Okay, I will not give same instruction again and again. Okay, one person is still. Okay, so how we will measure Fe plus 3? Okay, so Fe plus 3 iron, if it is present in your solvent, you need to precipitate it. And how you will precipitate it? You can precipitate it in by ammonium. Just a minute. You can precipitate this iron by adding ammonium chloride and ammonium hydroxide. Okay, so you need to precipitate ammonium chloride and ammonium hydroxide. Okay, as an analytical chemist, the question should be rise in your mind that why we are using two ammonium salt, ammonium chloride and ammonium hydroxide. And I think it is also explained in your 12th grade. Okay, why we are using means same ammonium salt. Okay, means after this reaction, okay, what we need to precipitate, it is iron hydroxide, ferric hydroxide, you can say. Okay, and this purpose can be solved by ammonium hydroxide only. Okay, this purpose can be solved by ammonium hydroxide only. Then why we are adding ammonium chloride also? Can anybody answer? Anyone has Anyone can answer this question? Why we are using ammonium chloride also here? Yes, very good, excellent. Okay, so here we need specific concentration of hydroxide ion. Okay, so how we can do it? We can do it by adding ammonium chloride. Okay, so ammonium chloride, when it will be ionized, it will also form two ions, which are ammonium plus chloride. Okay, so it will also provide you ammonium ion. Okay, so when ammonium ion will be there in your solution, it will prohibit complete ionization of ammonium hydroxide. Okay, and by this way you will get a required ionization of ammonium hydroxide. Okay, and by this way you will get particular concentration of hydroxide ion. Okay, and on that concentration iron hydroxide will be precipitate. Okay, and your purpose will be solved. That's why we are using ammonium chloride and ammonium hydroxide. Okay, I think it is clear. If you anybody has doubt, you can ask. Okay, so this is known as this effect. Okay, this effect is known as a common ion effect. Okay, so it is used to manage ionization of a particular salt. Okay, so this is clear, I think. Okay. So so here after this step you have precipitate ammonium hydroxide, but actually if you think deeper, so it is not only ammonium hydroxide. What is this? It is a hexa coordinated complex. Okay, sir already explained this thing. Okay, if you write it properly, the formula is H2O 3H2O OH. Okay, so here it is sorry, it is hexa coordinated species. Okay, so we cannot determine actual iron percentage here. Okay, that's why we need to do dry acing. Again we need to do here dry acing. Okay, so here again you need to put your sample in furnace, in crucible first, and then you need to put in furnace. Okay, where all water and filter paper which you are used here to filter this precipitate, okay, will be burned, and finally you will get here what? You will get oxide of iron, which is Fe2O3. Okay, after that you can weigh it. Okay, after the whole process, when crucible will get cooled, okay, then you just remove your sample and you can weight it, and you can find the weight of Fe2O3, and by here you can get weight of iron. Okay, so again if this is the question in your mind, how we will get the weight of iron by this oxide. Okay, so simple thing, if you know that H2O, okay, suppose water is there, okay, and I am asking you to find out the weight of oxygen. Okay, then how you will calculate? Okay, so you need to calculate there means what is the molecular weight of oxygen, what is molecular weight of hydrogen. Okay, and by this way you can find out that how much oxygen percentage is there in H2O. Okay, so total is 18. Okay, total weight of water is 18. Out of 18, 16 is oxygen. So like that you can calculate the percentage. Same concept you can apply here. Okay, to find out iron percentage. I think it is clear. Okay, then what remains? Okay, so this is all about the dry acid. Okay, now we are going to discuss about weight test. Okay, Now what is the weight acid? Okay, so generally suppose this is your metal ion M plus. Okay, M plus is metal ion like nickel. Okay, so nickel when nickel will react with dimethyl glycoxene, okay, it will make complex. Okay, like the just a minute. Dimethyl glycoxene, we need 2 amount of 2 ion because it is Na plus 2. Okay, so you need, or you can say, okay, like that, just a minute. Okay, so now nickel ion is coated with, or you covered by this dimethyl glycoxide. Okay, so for understanding only I can say, suppose this is the metal ion. Okay, like nickel, it is any metal ion and it is coated with any or we can simply draw okay, like that. Suppose it is coated with any organic species. Okay, and it is coordinated like that. Suppose I am making 6 hexa coordinated. Okay, here. Okay, so what I want to explain from here is your metal ion is covered by this organic species. Okay, so you need to remove this covering. Okay, you need to remove this covering. Okay, to analyze the metal ion. Okay, what is your main goal? Your main goal is to analyze metal ion, na? Okay, so how you will reach till metal ion? So first of all you need to remove this organic species which is surrounded your metal ion. Okay, so for this purpose we are using weight acid. Okay, so how you will remove it? Okay, so you can use different type of oxidizing agent. Okay, like HNO3. Okay, like nitric acid, H2SO4. Okay, sometime urea. Okay, urea means, I think you know the structure. Okay, it is okay. So when you will add this type of reagent, okay, so they will destroy this organic frame. Okay, this oxidizing agent will be destroy this frame. Okay, so by destroying this frame, okay, the organic frame will be destroyed. Okay, and the metal ion will be exposed. Okay, so this is known as a weight acid, means nothing, you are getting no S. Okay, but something is happening inside your solution. Okay, where organic part is getting destroyed by using this solvent. This is known as a weight acid. Is it clear? Weight acid is clear or not? Any doubt in weight acid? So for weight acid, generally people are use H2SO4 or urea. Okay, both means, so in a lecture, in second week lecture, sir explained that when you are using H2SO4, then SO3 will be generated. SO3 gas will be generated. Okay, after weight acid, but here nitrogen will be generated. Okay, so it is preferable to use urea, because nitrogen is not much hazardous compared to SO3. Okay, So nitrogen is inert gas and it is okay, but if it is if your process is creating SO3, then it is not permissible. Okay. So this is all about weight acid. Then okay. So if now we are going to discuss something a little bit about tools. Okay. So in our in analytical chemistry, volumetric glassware are being used like burette, pipette, okay, measuring cylinder and volumetric flask, etc. Pipette, burette, okay. But some other crucible, which we have discussed little bit, okay, crucible, then furnace, okay, oven, and different type of tools and apparatus are being used, okay. So here one type of crucible is explained in lecture, which is sintered glass or fitted glass crucible. Okay, this type of crucible has porosity and it can be used up to 200 degrees centigrade. Okay, so and another type of crucible which is Guch crucible. Okay, it is the name of Guch crucible is based on Frank Austin Guch, which invented this. Okay. This is the simple type of crucible. Okay, if you want to draw the structure, it is like that. Okay, it has like this is bed which has some pores. Okay, here it has some pores like that. Okay, and here you can fix any mat, filter mat. Okay, and then you can add your sample. Okay, so you can filter your sample generally. Okay, then after filtration you can directly put this sample in furnace and you can do dry acid. Okay, so this is it will create, means otherwise what you need to do, first of all you need to filter. Okay, filter in what is the common process of filtration? Okay, the simplest filtration we all know. Okay, so we need one funnel like that. Okay, we need funnel and here we need to put one filter paper. Okay, like that we need to put one filter paper, and after that if you pour your solvent solution here, then precipitate will be separate. Okay, after that you need to transfer this filter paper in your furnace for dry acid, but here you can directly the two purpose is solved in one step, first filtration and second is dry acid. Okay, so this crucible is known as Guch crucible. Okay, so I think it is clear. So filter paper is also classified according to their size, according to their porosity and pores available in the matrix. Okay, it is 40, 41 and 42. Okay, no need to go in deep side, but it is only for introduction. Okay, it is all about this thing. Then one more thing, it is analytical balance. Okay, so analytical balance is very precise and accurate balance. It is only balance. Okay, you all know about the balance. Okay, this is the simplest balance where you have two pens. Okay, one side you will keep weight and another side you can measure quantity of any substance. Okay, so this is the very broad or the very big type of balance, but analytical balance is also working on same principle, but it is very precise. Okay, and it is electronic, means the signals are generated by electronically. Nowadays electronic analytical balance are being used. Okay, and it is very precise because it can be measured in microgram. Okay, so according to balance, it can be classified according to microbalance. Okay, so again right, microbalance. So microbalance can be used, okay, up to 200 gram, okay, and the tolerance limit is only 0.1 mg, okay. Whereas semi microbalance, I will not write all this thing, okay, otherwise it will create a lot of, it will take a lot of time, okay. Second is semi microbalance, which can measure 10 to 30 gram, and tolerance limit of semi microbalance is 0.01 gram. And another and last is micro analytical balance, okay, which can measure 1 to 3 gram, which very low quantity, 1 to 3 gram, and the tolerance limit is very high, okay, it is means you can say 0.001, okay, milligram. So you can means what is the meaning of tolerance limit, okay. Tolerance limit means instrument is saying that I can be right or wrong below this limit, okay, means 0.001 milligram. Suppose you are for bigger view, suppose you are measuring your weight, okay, suppose you are measuring your weight in station, okay, this balance is saying that your plus minus 1 kg can be tolerance. Means suppose your weight is 55 kg, okay, then instrument saying that it can be either 56 or 54, okay. So it is my tolerance limit, okay. Your instrument is saying that plus minus 1 kg is my tolerance limit, so it is either 45 or 56. The result is showing 55, okay, but it can be 54 or 56, okay. So this is the tolerance limit, okay. So as you are going more precise instrument, the tolerance limit will be decreased, okay. Then another what we can say term used in balancing is tearing, okay. Another we can say tear, okay. So what is the meaning of tear? Tear means, because it is electronic balance, so when you on it, okay, suppose it is your balance and it is your display, so some limit will be okay, when you on it, some limit will be shown here like XYZ, okay. It is due to air or pressure gap or any, suppose any material used any material stuck on the pen, okay. Another analyst used in previous, okay, so some solvent is still there, or some substance is still there, okay. So it will create error. So what will you do? Here will be one button which is known as a tag, okay. So when you press this button, this reading will be converted in 0, okay. So whatever inside and whatever the things inside inside the balance, all things will be nullified, and finally your result will be converted in 0, okay. So this is the tearing. And again, last thing I am going to discuss about the weighing, okay. So how you will can weigh, okay. So before weighing, you have suppose you have bottle like that, weighing bottle, okay. So you can take empty, first of all you can take empty weight of this bottle, okay. After that you can keep this weighing bottle in your balance, okay. You can keep your weighing bottle in your balance, and then you just add your sample, okay. So now your weighing balance, weighing bottle is here, and you can add required sample here, and you can weight it, okay. After putting this weighing bottle inside, you can add your sample, okay. And after that you can take final weight, okay. Just a minute. uh, before okay, so what will happen if you tear it? Okay, so very easy process is what? Okay, first of all, before adding the sample, you can tear it. Okay, so your result will be again 0. Okay, the digital reading will be 0. Then you can add sample. Okay, and a required quantity of sample you can wait. Okay, so this is the very easy process for weighing of your sample. Okay. Then one more thing is used in your analytical chemistry is desiccator. Okay, so desiccator is nothing. Okay, so I can draw it. Okay, so here is for, this is for vacuum. Okay, from here you can generate vacuum inside this desiccator. Okay, and you can, this is one plate. Okay, at bottom of, there are two types. Okay, so you need to use desiccant. Okay. Desiccant is what? The chemical which can absorb. Yes. Okay, what is desiccant? So desiccant is the chemicals which can absorb water. Okay, or we can say hygroscopic. Okay, which can absorb water. So different type of desiccant like calcium chloride, calcium. Okay, then copper sulfate, P2O5, phosphorus pentoxide are being used as desiccant. Okay, so at the bottom we generally used first desiccant. Okay, and at this plate we can use secondary desiccant like potassium pentoxide, phosphorus pentoxide, sorry. Okay, so this is the working principle of desiccator. I think this is all about these lectures. Okay, so I have discussed little bit about the lecture. Okay, which being taught in second week. Just a minute. Okay, so we have more things to discuss. So student, I am giving you 5 minute break. Okay, you can take water and refreshment. We will start after 5 minutes. Okay, so you can. I will just join after 5 minutes. Okay. Hello, student. Yes, we start now. Okay. So now we are going to discuss. Okay, assignment of the previous semester. Okay, same course previous semester. Okay. So if meeting will be ended, then you need to join same link. I am telling for new student. Okay. Don't worry about the and don't take panic. Just join the same link. I will be there. Okay. So first question is what? In alkali fusion of pyrolusite is changed from MnO2 to. So we discussed about the alkali fusion. Na? We have already discussed in last means today's class only. Okay. In first session, what we discussed that because pyrolusite not able to dissolve in solvent. Okay. So what will happen? You need to add KOH or NaOH. Okay, and you need to fuse it. Okay, so it is known as a alkali fusion. Okay, so after that, what will be generated? Okay, so student, please listen carefully because this question will be help you to solve assignment. Okay, it is previous year assignment question, so it will be help you to solve the. Just a minute, sir. Is there any interaction session tomorrow? So I receive an email. Sir, no. I am not audible. Some Deepika Talor is saying that I am not audible. So please confirm whether I am audible or not. Okay, so please mute yourself, Nikhil. Okay, so what will happen? I told you, na. So when Mn2 will be alkali fused, okay, it will generate two types of ion, which are potassium permanganate and potassium magnet. Potassium permanganate, if it has two ion, then it will call as a permanganate ion, and if it has only one negative ion, then it is known as a magnet ion. Okay, so permanganate and magnet ion will be generated by alkali fusion of pyrolusite. Okay, but this thing should be clear in your mind why we are doing alkali fusion of pyrolusite. Okay, as an analytical chemist, you should know because we are not able to dissolve this in normal solvents. That's why we are going to use this alkali fusion. It is very energy intensive technique. Okay, compared to solvent dissolution, it is energy intensive technique, and we need to move toward alkali fusion only if we are not able to dissolve our salt or our compound in any solvent. Okay, so then So this is the explanation given here with chemical reaction. Okay. So in alkali fusion, pyrolusite is changed from MnO2 to MnO4 minus 2 and MnO4 minus 1. Okay. Potassium permanganate and potassium magnetite. Okay. So what are the reaction here? So reaction is when MnO2 react with KOH, potassium hydroxide, in presence of oxygen, it will make potassium permanganate. Here if you see why it is many of you are aware, but here K2 MnO4. Okay, so what will be there? Means this MnO4 has 2 negative ions. Okay, how you will balance the ions? Okay, so MnO4 it contains minus 2 ions. Okay, that's why it is attached with 2 potassium ion. Okay, and here it has only 1 negative ion, MnO4 minus 1. Okay, so these reactions are given here, you can note down. Okay, what is happening here? Okay, so this is potassium. Okay, then it is react with sulfuric acid and it will make KMnO4, MnO2 and K2C. Okay, so this is all about the alkali fusion process of pyrolusite. Second question is, which crucible is used for qualitative analysis of iron? Okay, so see, crucible, there are different type of crucible like silica crucible, porcelain crucible, goose crucible. Okay, so according to our application and according to required of our sample, okay, we need to select different type of crucible. Okay, so as I discussed in first session of this class about the sintered crucible. Okay, glass. So why we cannot use this type of crucible everywhere? Because it can use only up to 200 degrees centigrade. Okay, and if you want to use it on a higher temperature, then sintered glass or filtered glass crucible are not useful. Okay, so there are different type of crucible are named here. Okay, but for iron analysis we need to use porcelain crucible. Okay, which already explained in the lectures as well as class. Okay, so explanation is given here. During the analysis of iron sample, filtrate of FeOH3. Okay, so where you will get filtrate? On filter paper. I told you, on filter paper you will get brown color PPT of FeOH3. Okay, like that you will get PPT. Okay, so this PPT will be transferred in crucible. Okay, so it is transferred in porcelain crucible. Now here a goose crucible has perforated bottom that support a fibrous mat. This thing is already explained, so I will not explain again and again. Asbestos was one time the filtering medium. Okay, now asbestos is not can be used. Okay, because it is carcinogen and many issues with asbestos. Okay, so that but earlier days it was being used. Okay, so suppose this is the goose crucible. Okay, like that. But here you need some media, na? Here you need some media to filter. Okay, so earlier days here some asbestos was being used. Okay, but nowadays it is not. Glass crucible are manufactured in fine, medium and coarse porosities. Okay, the upper temperature limit for a sintered glass crucible usually 200. Okay, that's why sintered glass cannot be used for higher temperature. Okay, only up to 200 degree centigrade we can use. Porcelain, aluminum oxide, silica and platinum crucible maintain constant mass. Okay, so this is very good thing which I think I should explain. Okay, why we required crucible? First of all, if you will tell, sir, if I have filtered, Okay, I will simply transfer my filtrate in some pot, and I will keep in furnace, and things will burn out. Okay, so why we are required different type of crucible? Okay, so the answer of this question is why we require different type of crucible, because crucible are generally inert. Okay, inert with many chemicals. Okay, so they will not react with your sample. Okay, and if it will not react, then after drying, or after you can say dry acing, your sample will not contaminate. Okay, and you will get accurate weight of your sample, and purity of your sample will also not destroy. Okay, that's why we need crucible made of this type of material, which are very inert. Okay, which are very inert to our chemical. Okay, so that's why we require this type of crucible. Okay, some type of crucible are not explained here, but if you will see in higher grades, then some platinum crucibles are I am getting some voice. Deepika, please mute yourself. Deepika Thalor. Okay. So what will happen? Yes. So platinum crucible is platinum. You know that platinum is very costly metal. Okay. So why we require platinum? When you are going to analyze silica. Okay. When you are going to analyze silica, so you need to use HF, hydrofluoric acid. Okay, this hydrofluoric acid is very reactive. Okay, and it can react with crucible also. Okay, that's why uh, in the analysis of silica we require to use platinum crucible. Okay, it is very costly, but we do not have any option. We need to use platinum only. Okay, so here, so there are many constraints in using crucible. So according to our sample, let me mute. Deepika, please mute. I am not able to mute you. Please mute yourself. Okay, so I think my screen is visible to you. Okay, answer of this question is visible. Okay, so platinum crucible maintain constant mass within the limit of experimental error. Okay, and are principally to convert precipitate into suitable weight. Okay, so means what we can say, that these materials which are used to make crucible are chemically inert. Okay, it might be that some reaction can be happen with this material also, but it is under the experimental error limit. Okay, so this type of error we can sustain. Okay, so that's why different type of crucible are made and being used for analytical chemistry. I think it is clear. Any doubt about this question you can ask. Okay, question number 3. Question number 3 is, which reagent effective in removing nitrate ion and nitrogen oxide from acid solution? Okay, so we need to remove nitrate. Okay, so obviously we will go with urea, because after that it will create nitrogen and it is safe and effective. Okay, it is safe and effective. That's why we should go with nitrogen. Okay, so nitrogen means how nitrogen will create? It will create from urea. Okay, so right answer will be urea. This is the explanation of this answer. Urea, also known as carbamide, readily produced from ammonia and carbon dioxide. Okay, so from the structure you can see, okay, that how urea will Okay, so by structure you can say it contain two ammonia unit, and this is come from carbon dioxide. It is CO, so it is come from CO2. Okay, so by structure you can say it is made from ammonia and carbon dioxide. This part will be made by carbon dioxide. Okay, is a very important chemical in agriculture also. Okay, urea is a fertilizer, we all know, and polymer industry also. Urea is used to remove nitrogen dioxide and nitrate from acidic solution. Okay, so this is the explanation of question number 3. Question number 4. How can you physically separate a liquid sample from liquid mixture? Okay, so what we are going to separate? Liquid from liquid. Okay, so it is this technique is already explained. Okay, how we can separate liquid from liquid. Okay, we will discuss one by one. Filtration and diffusion. So filtration is not possible. Okay, for filtration one thing should be solid. Okay, so it is not applicable. Then distillation and decantation. Okay, so this can be, okay, because distillation can be separate liquid from liquid, and by decantation also we can separate liquid by liquid. By solubility difference and diffusion. Okay, so it is not applicable for our sample. Density flotation and solubility difference, it is used for solid to solid separation, as we discussed. Okay, it is used for solid to solid separation. So this is also wrong answer. Okay, solubility difference and diffusion, so it is used for gases, it is also not applicable. Okay, so clearly we can say by distillation and decantation is possible. Both processes are explained. Okay, if you remember, then both processes are explained nicely in previous portion of this class. Okay. So yeah, a solid sample can be separated from solid mixture by density flotation. Okay, density flotation means what? If you are keeping the chunk of your sample in a solvent, okay, so due to density diffusion, one solvent will be flowed at the top and another due to high density will be precipitate at the bottom, and by this way you can separate two solid from mixture. Okay, and also solubility difference. Solubility difference means if one solid has higher solubility compared to another, then it will be soluble, and it will make solvent with particular it will make solution with particular solvent, and remaining solute can be precipitated. Okay, a liquid sample can be separated from liquid by distillation and decantation. Okay, a gaseous sample can be separated from gases by diffusion, gas chromatography. Okay, which I explained you how column. Okay, in gas chromatography, what is the principle of gas chromatography? Gas chromatography is it has column. Okay, and in column something is filled, which is known as absorbent. Okay, and when gas will pass from this what we can say column, okay, according to their absorbance with this material, okay, gases will be separate. Suppose A will be absorbed here. Okay, suppose you have a mixture of A plus B. Okay, so A will be absorbed here and B will be only reach toward the end of the column. Okay, so by this way, this is the simplest explanation of the principle of chromatography. Okay, from where you can separate gas from gas. A solid sample can be separated by liquid mixture by filtration. We know that. Okay, it is simple thing. Solid, if it is solid is there in your solution, then you can filter simply filter it out. Okay. Then question number 5. What are the steps followed for the processing of solid sample. Okay, means you are going to prepare sample. So whenever you are going to prepare solid sample, what should be step? Okay, so solid sample always be found in chunk. Okay, so you cannot analyze chunk. Okay, what you need to make it fine powder. Okay, from the chunk you need to convert it in fine powder. Okay, so this is the very simple thing how we can convert in fine powder. Okay, so crushing, washing is not included, melting is also not included. Okay, crushing, pulverizing and grinding, okay, it seems good. Then melting, no, melting is not required, evaporation is also not required. Pulverizing is good, grinding is good, but evaporation is not. Okay, so right answer should be B. Okay, so these are the steps which are being used for preparing of solid sample: crushing, pulverizing and grinding. So yes, B is the right answer. During the processing of solid sample, it is very important to bring homogeneity. Okay, why we are converting a solid chunk? Why we are converting solid chunk in powder form? Okay, because we need to convert our sample. We need to homogenize our sample. Okay, just a minute. Okay, so we need to homogenize our sample, and to homogenize sample, crushing, grinding and pulverizing are being used. Okay, so I think it is clear. Okay, homogenize, if you don't know about the meaning of homogenize, so homogenize, what is the homogenization means? If your mixture is not if you are not able to identify the constituents of your mixture, then it is known as a homogenize. Like if you are adding alcohol in water, okay, then you after mixing you cannot differentiate that this part is alcohol and this part of water. Okay, so this is known as a homogenization. Like in solid, if we are going to give example, then we can say alloy. Okay, so what is alloy? Alloy is a mixture of two or more metals. Okay, suppose if you have mix alloy of copper and zinc. Okay, if you have alloy of copper and zinc, then you will not able to identify that where is copper and where is zinc. They both are mixed together and you will not able to identify very easily. Okay, sir, please tell the meaning of okay, I will explain it. Okay, so pulverizing is also one technique where you are using crusher, okay, to convert your sample in smaller part. Okay, crushing means what is means of crushing and pulverizing, this both are look like same. Okay, but in crushing you are going to convert big chunks, okay, in small parts. Okay, like that. But in pulverizing you are going to convert these small pieces of your sample in powder form. Okay, so this is known as a pulverizing. Okay, in pulverizing you can convert in mm and micro size of your sample. Okay, then sixth question is, which apparatus are used for measuring volume reliably? Okay, so volume measurement is very important. Okay, just a minute. Okay, so why volume measurement is very important? Because suppose you are taking 1 liter milk. Okay, if you are going to take 1 liter milk, okay, and if you have two type of suppose three type of okay. Okay, my drawing is not very perfect, but I just want to explain you. That's why I'm going here. Okay, so suppose you have three type of beaker, or you can say three type of pot, where you are going to measure 1 liter of milk. So uh, which pot you will select? Can anybody answer? Please answer me in a message in chat box. Which pot will you select to measure 1 liter of milk? First, second, or third? Very good. Volumetric flask, measuring cylinder of 1 liter. Okay. First. Okay. So yes, very good, Nandini. Okay. So sorry. See, if you will measure 1 liter from the measuring cylinder. So suppose the first pot is measuring cylinder. Okay, and it is marked here that it will be 1 liter up to here. Okay, it is marked here and it is marked like that. Okay, so if you are going to measure 1 liter, then then your pot should be filled up to marked point. Okay, in first, if you are going to select measuring cylinder, then you need to fill it here up to here. Okay, but the area of your cylinder is very broad. Okay, so you cannot measure this meniscus perfectly here. Okay, now if we are moving towards second pot, then it is also broad, but it is narrow compared to first one. Okay, it is narrow compared to first one, so you can measure milk little perfectly compared to first one. But here, if you, this is the volumetric flask, here the neck is very thin. Okay, so you can measure the meniscus very perfectly here. Okay, so I will, if you are going to measure volume, I will recommend that you need to go with this A, then you need to go B, and if you don't have A and B, then you need to go with C. Okay, so by weighing A, you can measure your volume perfectly. Okay, so so the analytical chemist should be used volumetric flask to measure any volume. Okay, okay, I think it is clear. Any doubt, you can write in chat box. Okay, okay, understood this thing. Okay, so now we can answer this question. Which apparatus are used for measuring volume reliably? Yes, pipette, burette, and volumetric flask. Because pipette is very thin. If you see pipette, it is very thin. Like burette is also very little bit broader, but it is also very thin. Okay, and volumetric flask I have already explained. So A is right answer. Funnel, we cannot measure. Obviously, we cannot measure volume by funnel. Beaker also we cannot. We can measure by beaker, but only estimated volume. We cannot measure perfect volume. Okay, volumetric flask is right. Pipette, funnel is right. Wrong here. Round bottom flask, but it should be means sometime only we use round bottle flask, and it has scale then only. Then burette, desiccator, no, desiccator cannot be used. Crucible cannot be used. Okay, so A is right answer. Yeah. Okay, so A is right answer of this question. I will just read this explanation first. Volume may be measured reliably with pipette, burette, and volumetric flask. Volumetric equipment is marked by manufacturer to indicate not only the manner of calibration but also the temperature at which calibration is strictly applied. Okay, so it is also very good point. Temperature also you need to worry about. Okay, because if you are going to measure your any liquid at 100 degree centigrade, and if you are going to measure at 150 degree centigrade, okay, and you are using same volumetric flask, okay, suppose you are going to measure same volumetric flask, but it might be that at 150, suppose, or suppose we can say that I filled one liquid here, suppose it is 1 liter, okay, and temperature was 100 degree. When I measured this volume, it was 100 degree centigrade, okay. Then I gradually increase the temperature up to 150. So what will happen? Okay, so what will be happen? The volume will be increased, okay, and it will be, it might be reached up to here, suppose, okay, suppose we are assuming it might be, so it move, so the volume increase from here to here, okay. So this extra volume will give you false reading, okay. So if you are going to use any volumetric flask, first of all you need you have to read that which temperatures are mentioned, that which can be used for measure volume, okay. So we cannot use any liquid at any temperature, okay. Suppose it is given at room temperature, like at 25 degree centigrade you can use. So for 25 degree centigrade you can use for any liquid, but you cannot use it for higher temperature, okay, it will give error. So the temperature is also very important, okay. Pipette and burette are usually calibrated delivery specific volume. Volumetric flask, no other hand are calibrated contain specific volume, okay. So these things are explained. Yes, somebody is asking pipette, burette, volume. Yes, obviously. Good. Nikhil, yeah, your answer is right. Okay. So only 10 minutes are remain. I have to cover a lot of questions. Okay, I will move just a little bit fast. So in nickel dimethyl glycol complex, the destruction of the organic liquid by treating with mixture of HNO3 and H2SO4 is processed. Okay, we have already discussed what we are doing with using of nitric acid and sulfuric acid. We are just destroying the organic part which covered metal ion, okay, which I have already explained. So it is known as a wet acid method, okay, it is known as a wet acid. So this thing is clear, I think, okay, yeah. So I am just the conversion of organic compound into S, okay, or we can simply say decomposition of organic part by treating the compound with nitric or sulfuric acid is known as wet acid process. In nickel dimethyl glycol complex, the destruction of the organic ligand. What is the organic ligand? This thing is organic ligand, dimethyl glycol. Okay. So by adding nitric acid and sulfuric acid, you are removing the surrounding of dimethyl glycoxine of nickel ion. Okay. By treating with mixture of nitric acid and sulfuric acid. Okay. I think this wet acid process is clear. Any doubt you can ask in chat. Okay. Question number 8. What is shown in the following picture? Okay. So this instrument is known as desiccator. Okay. This is known as a desiccator, and it is you can see this is the crucible. Okay, why we are putting crucible inside this desiccator? Because it will protect your sample from the moisture. Okay, primarily from moisture. Okay, it will also it is also vacuumed. Okay, so it is the air inside the desiccator is removed by what say vacuum by doing vacuum of this desiccator. Okay, so it will be vacuum and no moisture, no other gas will be present inside this desiccator, and your sample will remain safe. Okay, so obviously it is a glass desiccator and this is the silica crucible. Okay, so D is the right answer of this question. One is desiccator and another is silica crucible. Okay, so explanation of this answer is the following image shown is component of typical desiccator and silica crucible. The minimized The uptake of moisture dried material are stored in desiccator while they cool. The base section contain chemical drying agent. Okay, chemical drying agent we have already discussed, such as anhydrous calcium chloride, calcium sulfate, anhydrous magnesium perchlorate, anhydrous or dehydrate, or phosphorus pentoxide. This example already discussed. Okay, so no need to explain again and again. The ground glass surface between the top and base are lightly coated with grease to ensure good seal when top in space. Okay, so why we are using grease and where we use grease, I will just give you simple thing. Yeah. Okay, so this is the, you can say, cover of desiccator. So when you put the cover on the desiccator, here, okay, this connecting surface should be the connecting surface should be properly isolated. Okay, and to make it properly isolated, we use grease. Okay, so why we are using grease? So after using grease, air moisture will not able to pass through the gaps available in these two surfaces, and your sample will remain safe. Okay, clear why we are using grease here? Okay. Question number 9. Choose the correct statement given below. Okay, so we need to use. Okay, so by you as explained by sir, you can this is very common, very simple answer. Maximum weight capacity of semi microbalance is 1 to 3. Okay, and no, it is not right answer. Okay, this limit is not right. Okay, then maximum weighing capacity of microbalance is no, 500 gram is not, it is 200 only. Okay, maximum weighing capacity of semi microbalance is 10 to 30, but accuracy no, it is not right. Okay, then semi microbalance is maximum weight capacity of semi microbalance is 50 to 100 gram, and accuracy is 0.03. Okay, so it can be clear by this table. Okay, see, so answer A is correct, where, just a minute, let me see what happened. 200 gram, and so I think answer A is this is the wrong answer. Okay, because maximum weight capacity of semi microbalance is 1 to 3 gram. Okay, just a minute. Semi microbalance. Okay, semi microbalance. Yeah, so this is the right. Yeah. Okay, so information about the semi microbalance are given, right? 10 to 30 gram and 0.01. Okay, so by this table you can compare. Then question number 10. Only 3 minutes are remaining. Which reagent is used to quantitative analysis of Fe plus to get? Okay, so it is already clear. We have discussed common ion effect. Okay, so ammonium hydroxide and ammonium chloride are being used. Okay, so these solvents are being used to precipitate ferric hydroxide. Okay, brown PPT, and this brown PPT can be further used for iron estimation. Okay, so answer of this question: the mixture of ammonium chloride and ammonium hydroxide are used to quantitative analysis of Fe plus to get brown Fe plus FeOH3 precipitation. The precipitate is filtered and taken to porcelain crucible to heated and get FeQO. After that, you can find out iron quantity in your sample. Okay. Last and final question. Identify the correct statement from the following. Okay. The upper temperature limit for sintered glass crucible is usually about 200 centigrade. Yes, it is right. Okay, so first statement is right. Second is porcelain crucible is used for acing of filter pressure paper. Yes, where we use porcelain crucible just in previous question for estimation of iron. Okay, so here crucible is used to acing the filter paper. Okay, so first of all FeOH3 ferric hydroxide precipitate on filter paper, then this filter paper transferred in crucible, and finally it is converted. Okay. Third is, so this is also right. Third is crucible are used principally to convert a precipitate into suitable weighing. Okay. Yes, suitable weighing form means, what is the meaning of this sentence means you can weight, you can proper weight. Okay, what is meaning of proper weight? Why we cannot weight ferric hydroxide? It is also precipitate, no? So we can use it is by ferric hydroxide only. Why we are doing this thing? But because it is not purely FeOH3, it is a hexacoordinated ion, okay, which cannot measure accurately. Okay, so it will give error. So that's we need to follow one more step, and we need to convert it in Fe2O3 form. Okay, so this is also correct. Okay, so all of the above options are correct. Okay, so I think it is D is right answer. Yes, D is right answer. Okay, let me read it. Okay, crucible are used primarily to convert precipitate into suitable weighing form. Porcelain crucible are used in muffle furnace to loss in ignition testing of cement, fly ash, soil material. Their temperature rate 1000. Okay, so it can be heated up to 1000 degrees centigrade. Okay, they have high form design and glaze inside and out. Okay, glaze means polished. Okay, except from the outside bottom and rim. Upper temperature limit of the sinter glass 200 we have already discussed. So now, okay, so this is the end of the class. If you have any question, you can write me. Okay, I will clear it. Okay, thank you.